Clint,
Colette,
how are you doing?
I'm doing very well.
I feel like I
much.
just asked you that.
I feel like you
I
might
did.
have, yeah. We're doing it a little weird today, yeah.
Yeah, we're doing a little post recording chat to introduce a very special thing that we got to do together, which is that we had John Allspaw and Dr. David Woods on the podcast. Got to chat with them for a little bit. And I should say Dave did most of the talking. In the
I think we
best
may
way.
have to give John another episode. But
John gets all the
to be
I feel
expected.
Like John will just keep joining us all the time, and that will be great. He's like, yeah, he'll just be hanging out like our friendly neighbor. So we had gotten a question and we were talking through, and I remember this now very vividly, which is that we got a question and you were looking through it and you were like, oh, this is a really interesting question about like systems thinking or whatever. And he was like, and you like, I think you Googled it, some stuff or something. You like did your little Google Scholar search and you were like, oh, I think we have to have Dave Woods on. And I was like, all right, this is it. This is the one.
Yeah, I mean, Dave is obviously a legend and more in our community, and we've been wanting to have him on and talk about something. Systems thinking felt big enough. I don't think it was, but he certainly filled in some like his thoughts on the system thinking were really interesting, but it led to such a bigger conversation, which it always does with Dave. I've been to a few AMAs with him at conferences, and it's always just like, we're all like, oh my God, there's more. There was more.
It makes me think he's professor emeritus now at OSU, but it makes me think that it would have been really cool to like be in an actual classroom listening to him expound on all the things over many semesters. That's how I feel whenever I talk to Dave. I'm just like, oh, I wish I could sit with you like more regularly and just learn through listening more. But we got a chance to do that for a little bit this time around, and we are in different cloths. We've already recorded this episode, so you could tell this is a post-recorded intro. Yeah. But I did want to read a little bit. John Allspaw, everybody already knows, I'm sure has been with us a few times now, I think. He has worked with software systems engineering and operations for over 20 years. His publications include the book The Art of Capacity Planning and Web Operations, as well as the Forward to the DevOps Handbook. His 2009 Velocity Talk with Paul Hammond, 10 plus deploys per day DevOps cooperation, helped start the DevOps movement. John served as CTO at Etsy and holds a Master's of Science in Human Factors and System Safety from Lund University. He is a principal at Adaptive Capacity Labs. Dr. David Woods founded resilience engineering as an approach to safety in complex systems in 2000 to 2003 as part of the response to several NASA accidents. David is currently professor at The Ohio State University in the Department of Integrated Systems Engineering, with pioneering research on the interaction between humans and technology and risk-critical activities for almost 40 years. His book on safety and resilience engineering includes Resilience Engineering, Concepts and Precepts, Behind Human Error, very famous one, and Resilience Engineering in Practice. Dave is also at Adaptive Capacity Labs. Hello. Hi.
Hello.
Welcome.
Hello.
John and Dave.
Welcome to the podcast. I'm so excited, Dave, to have you here. And also, obviously, John, although I feel like John is basically like would be tagged, if we were a show, like a TV show, John would be like a recurring series character. So
Wait a
welcome
minute.
back, John.
Am I the what character am I? I must be, am I Cosmo Kramer in this situation?
I don't know.
I think you are our Kramer,
Maybe
yes.
a little.
Just bursting in, muttering.
But very, very awesomely, we have Dave Woods joining us. I'm I'm so excited to have you here. I also am. I have to say, Dave, every time I run into you, I'm like this much intimidated and this much excited. So, and
I'm
and I
sorry.
and no, it's not your fault. That's a me thing. But I think it's like it's one of those things where we have this podcast. It was meant to be kind of like we're gonna bring some resilience engineering or like generic like safety discussions into like the software world in like a very practical sense. And it's so amazing and incredible to have you. Like I feel like you are the the founder of a lot of this thinking, and so it's just a real honor to have you here. Thanks for joining us.
Well, actually, it runs both ways because the best world for seeing all of the things playing out, where we can see the fundamentals, things that sound real sciencey and theorems and all kinds of stuff, but it's all very practically playing out since I got introduced into your world, and why I immediately said, you are the future everyone else talks about, and it turns out it didn't. It's not as advertised, and that continues to be the case as people advertise more cognition for free, mechanization of cognition, and also the things that we anyway, and so you're in the center of this as AI coding versus software engineers coding, misrepresenting how critical digital services work, because in the end there's coding, and you're like, I think you missed a few system levels here. Maybe that was a lead-in.
Yeah,
I feel like the world just got a reminder about this, though, right? As we're recording this, Monday was a big AWS outage, and I heard such effects as I couldn't check my kid into their daycare. Right? I couldn't. I personally have an Amazon grocery store near me, which I despise but still go to, and they could not do anything except take cash. Like, we're getting a little reminder. None of that's AI. That's simple, complex systems compared to AI automated, checkout systems. So I feel like the world is having a moment of stepping back, but I know that from past experience, it's probably going to be brief.
People who couldn't get their healthcare records at their doctor's appointments, like that was another one. Speaking of like healthcare and that, it's pretty bananas. How
computers were a huge mistake.
Yeah, I tell
no,
myself
it's just
that
the
every
internet
day.
that was a mistake, John. Computers are fine.
True.
So I wanted to. We always start off, Dave, with a question from a reader, and I was trolling our question list for something that's might be appropriate to you, and we pre-mentioned it to you, and you said it's a trigger word. So I'm gonna go ahead and we're gonna trigger you live on live on this recording. So we had a question come in, and it was in a bank of questions from the same person. We've covered one of them already with our friend Lauren Hochstein, but which was about what's the difference between root cause and incident analysis. Now, what's interesting is the line right below that in this person's question was, what is systems thinking? And we thought, who better to answer
better to trigger
than Dr. David Wood? So, do you want to? What is systems thinking?
Well, so of course the irony is I am a professor in a systems engineering department whose title is Integrated Systems Engineering, trying to reflect changing reference for what the word system means. And for many fields, the word system is relevant and different than other fields because it's kind of a relative statement, right? And it becomes very ambiguous, therefore. So I may be working on some piece, and then I talk about how that fits in a larger system, or it has to interact with other parts of a larger system. But that larger system is a piece in some other system. And so the word system quickly deteriorates into vacuousness.
Mm-hmm.
And this is common in many fields that are oriented, that have base words that everyone uses, and it doesn't really mean anything, but we use the word all the time. And then you have the other word to go with it, thinking. And as long as there has been people, there has been debates about what is thinking. We can't go back to the moment of spark. Maybe it was Prometheus and fire, or I don't know what, but anyway, whatever it was, we haven't stopped arguing about what thinking is, in part because we don't have conscious access to many aspects of how our mind works, how we see, how we shift attention, how we understand, how we learn. I just got off a podcast talking about expertise, the attacks on expertise today, and they're mostly long-standing. And the word learning didn't come up much. And so very quickly, right, we can talk about how many aspects of how we learn are kind of inscrutable to our thinking mechanism, which does learn all the time. And one of the classic things about learning is that it is effortful, and it takes, and it happens in a local frame. Some agent learns something, right? And it takes effort and contact with information, experience, variability in order to learn. Now you take another perspective and you go, I want you to learn something. And what's the big discovery people have eventually? That what I thought I was teaching you, what I thought you were supposed to learn, isn't remotely what you learned. You learned something completely different from the contact, the information, the interaction, the variability. And so, fundamental issues like perspective come into play. And all of a sudden you go, okay, wait a minute, there's systems. And you go, no. Actually, that's one of the big mistakes that people make in understanding the word system. They start to think they can look at it from the outside in. I stand outside and there's the system laid out and I can see the different parts. And the answer is no. But we now know fundamentally and completely and absolutely, you're always somewhere in a system. You're never outside a system. Now, you have a local view of what's around you in the system, what you deal with, who you interact with, what you do, what activities affect you, what activities you affect. And also you can take regional views. You can step back and look around, but it's never an omniscient perspective. It's never a total one. And that's very well illustrated in modern critical software infrastructure that underpins everything, that there's no way to map all the interdependencies. There's no way to draw a map put it on the wall of all the parts and how they interact. Any attempt at mapping from the outside in is partial, loses things, hide things. And of course, that's one of the fundamental, theorems, constraints on how we understand the world, that the view from any single point of observation simultaneously reveals and obscures. So what right there, we kind of blew up both thinking and systems with just those couple examples, right? Perspective taking matters. Different perspectives reveal different things. If you can contrast perspectives, you see more than what you can see from any single one. The view of the world is inherently requires you to be able to revise and reframe. Often, again, people want it. I have the system, and here's the picture of it, and here's the parts. Here's the parts.
Look at the drawing Clint has in the background.
That's
There's my
right.
system
Yeah.
right there.
That's
It's
right.
all there.
Yeah. And it's one of the reasons why we never draw box and line diagrams. Everything in the lab has to be. It's been this way for all the teams when I was in industry too. You have to draw cycles. You have to draw circles. There's a whole bunch of things behind that, but the point is, often in our attempts to draw out a system, all the actions in the lines, but we focus on the boxes. Right, that's what most of the visual imagery is the box and the labels on the box and the icons on the box and the tabulations about the box. No, the action's all in the lines, in the relationships between the parts. So the quick answer to what systems thinking is escaping from linearity assumptions, escaping from the reductionist tendency, escaping from thinking a system or wholes are simple sums of parts. You mentioned the root cause thing.
Yeah.
And there's many ways in which that is a conceptual error, a deep conceptual error. But one part is it's making linearity assumptions. And this was one of my first run-ins with the systems engineering per se in the aftermath of the 3 Mile Island nuclear accident. Which was very much about emergent system properties, forms of complexity, ways failures could, small things could combine in a way to create the equivalent risk of a large fail, what was thought of as a single large failure, in ways that made it very hard to understand and act effectively in the situation because of the uncertainty and noise and things. And so very quickly, we're dealing with emergence and patterns and relationships. The information's in the relationships. So my background in trying to understand how people find meaning in the world in a very specific way, like how the hell does your brain work? Right? How does it see the world? How does it know when to shift attention, when to concentrate, and when to be sensitive to new signals? That it's all about the relationships between the parts, not the parts. And in those relationships, we'd end up having new levels, and we're not going to call them at levels ever. We're going to call them layers. And so new layers emerge, right, from the interactions of parts. And those new layers are real, but they don't exist without the parts because they depend on the relationships between the parts. And that's really, really hard for people to grok. And so it's very easy for them to oversimplify. And so we have the classic findings from Paul Feltovich, who passed away in January this year, and his colleagues about these oversimplification fallacies, tendencies. And of course, there's one that's very salient in our world right now, which is everybody says the AI, the AI. And that, what's that? It's a whole bunch of interacting parts. Right, a whole bunch of dependencies.
2 letters, like artificial intelligence, both very, very linear concepts, right? Like that just smack together easily and produce a simple thing, right? Like, that is a great example of how we're like over linearizing things.
That's right. The reification
if I can ask you
fallacy.
about is the incentives that lead to these things getting so much airtime, right? Like we're talking about systems thinking. System thinking, like when people ask me to, well, if I was using systems thinking here, which I'm not sure what they're saying there, they're asking me to like step out of that linear pattern. And one of the reasons that even I, as somebody who kind of is aware of these oversimplifications, gets pulled into that linear thinking is that there's constant pressure on us to summarize, to narrow, to produce results as an engineer, results that are consumable by those who are not at this level of complex thinking yet. And what I kind of see in the little bit of reading I've done about system thinking is that it's trying to like give people some linear ways to get there, which I think is kind of ironic. But this is what I'm always worried about when I get into resilience engineering context with people is everybody's at a different level of thinking. So, What do we do with that? Where, like you say, AI, somebody wants to say, well, why don't you just throw some AI at it? Right. And now I want to give them a resilience engineering perspective about that and help them get those layers. That's where I get tripped up.
Well, first off, I mean, you brought up two actually quite distinct, important points. The first one is that pressure encourages people to oversimplify, and it's one way that narrowing goes on. And research has highlighted for a long time narrowing versus broadening. And so heuristics that help you broaden, right, explore more perspectives, integrate across more perspectives allows a whole bunch of things to work better. Insight, recognition, anomaly response, hypothesis generation. I mean, a classic one, very relevant to you, is an anomaly response. What's an anomaly? And a step that's missed is hypothesis generation. And guess what? No one by themselves will generate all the possible hypotheses to explain an anomalous set of findings, right, or behaviors. So what happens? You need multiple sets of experience, multiple sets of knowledge, multiple perspectives in order to generate more possible explanations for what's going on, and therefore better ways to understand what could happen next and what to do to keep bad things that are about to happen next from actually happening. And so classically, there's a bunch of things: cues, fresh perspectives, different representations to help you reframe the situation. These are all things I studied when I hit the ground running in the real world. And we're going to come back to this, that what you see when you hit the ground running in the real world is different than what you can see when you pull pieces of that real world out and squish it down and try to stick it in on a lab bench, in a room or whatever. You miss things. Just like you say, no matter how much you test, you can't be sure on how your system will perform. The system you've been changing, adjusting, improving will perform when it makes contact with real production traffic under real conditions of variability, changing loads, changing uses, changing purposes, changing customers. And that the ability to simulate the full complexity of reality is a delusion I'm hearing more and more about. And the example is digital twins. And somebody maybe later I'll bring up a silly example of digital twins, not to pick on an old friend, but the second one is, and I want to emphasize the keyword you didn't use, and that would be relevant to systems thinking, and that is, we often use the word analysis, but classically, at least to the Greeks, I'm sure somebody had it before, analysis is only a portion of a cycle. The cycle is analysis and synthesis. And so the issue you're bringing up, if we step away from the pressure of handling anomalies, challenges, and surprises, and say we're just trying to understand systems, design them, whatever, plan tests, etc., is there's a synthesis component over analysis that is often ignored. And this is where we see oversimplifications like data is the equivalent of information, or manipulating data is finding meaning. Meaning is much more than significance, right? Means contact with someone who holds something, holds a problem, who has a stake in it. Some consequences accrue that affect them when things work out or don't work out. Again, it is a thing where we say it's local. There's somebody there in that place in the world experiencing this stuff. And so synthesis is underplayed. It is currently under huge assault, and the degradation. It's always been hard to teach people. I mentioned learning earlier. It takes effort to learn how to do to work the full analysis synthesis process. It is a skill, and it grows through practice, contact with variable challenges. It benefits from interaction with others, engaged because of the uncertainty and noise when you're doing synthesis in parallel with analysis. And so it has all these properties. And what do we see, like we've seen for my 50 years, is the pressure to get it for free. If we could just mechanize it, I'll have it for free. I'll get leverage. I'll pay once, and then I get it all the time. And not only that, I don't have to deal with those variable people who, right? Who
Synthesis
have a role
doesn't scale,
people
Dave.
so annoying. Yeah.
And well,
What was evolution thinking?
They might have something different. They might have a different way to do things than my top-down plan. And so this Anglo-American myth in the business management world that a top-down command hierarchy can work effectively, which has been disproven over again. I mean, if you look at my command adapt paradox chapter, it's very short. It points out, everything is like, well, the modern classical reference for this finding is Suchman 1986, but it actually goes back to 1806. The classic modern finding is, Woods and Roth, but it really goes back to Norbert Wiener in 1950. I mean, we discover and rediscover these things, and then we go back to what's just JFW. And I'm just running out of patience at my age, and I just want to say that's JFW. Just fucking wrong.
But it was, in the fetid halls of LinkedIn posting the other day, I saw somebody say that, the popular style of management as enablement and like servant leadership and like creating a great culture to work in has been proven to not actually matter, because if you look at the top 500 performing companies on the by their stock price in the last 20 years, not all, most of them don't practice the fuzzy happy management. And I just sort of, I almost spit out my coffee because I thought, what a funny way to measure success.
What a nice, clean
about
analysis they did there.
Yeah.
I think they missed. Somebody told them that your stock price has anything to do with anything.
With anything, yeah.
No, it's all your fault and your win.
Yeah.
It's
the
easy.
destruction.
You just push this way and it goes up, and you push that way and it goes down.
Well, we have a
Clint.
few organizations whose their viability has been crushed over the years from continuous deployment of those narrowing pressures on a few criteria, and that it's really actually. We were joking before we started recording, and that I should have studied more of my psychiatric disorders to apply at a societal scale. Not my specific disorders, but the general catalog of such disorders.
Collective mania, yeah.
But you're referring to an obsessive compulsive disorder at a societal scale. That these few indicators cover everything. And you see the problems with that today. Switching settings would be in cardiology and emergency medicine as private equity tries to take over those services because they can extract financial resources. And the more financial resources you extract, that's for a purpose, which is they make money.
Yeah.
Right? They extract money for themselves, for a few. But extracting that money means less resource to actually take the purpose of healthcare, which is to actually treat patients.
It's incredibly well documented that when private equity takes over hospitals, that patient outcomes are lowered, right? Are less good.
And so the narrowing example, Clint, is very clear there. And this was one of the first things we wrote about in resilience engineering. was that if you have short-term intense pressure, you will narrow and you will end up eating the sources that contribute to your ability to express resilience, to have resilient performance in the face of challenges and surprise. And it will seem okay until it doesn't, and the system is in danger of a brittle collapse. So you're inadvertently increasing the brittleness. So this becomes the one of the basics here is that we design competent but brittle systems. They fail less often than they should. And why? Because there's an ad hoc source for extensibility as they approach saturation, as they approach the boundary where brittle collapse, where they run out of the capacity to deal with the challenges and et cetera. And so some people adapt. And those forms of adaptation can be very local and repair-oriented to keep things going. They can be broader and more innovative in other ways. But people as an essential source. And of course, what's one of the things, which is people can be a source of graceful extensibility. They don't always do it, but some people will do it, as in the emergency medical system when they're slammed by beyond surge capacity events. They will keep going to try to serve the injured parties. But machines don't. And we have never tried to design machines that would exhibit extensibility at its boundaries. And machines don't understand or have an ability to appreciate what it means to approach saturation in the way that the new findings indicate. And so it falls to people to do it. Now, can we help people and can we design machines that participate in the process? Well, ironically, you guys do it a little bit. And I've had talks where we run into it that you don't, right? You have a bunch of kinds of incidents which you can handle because you do have ways of adapting in the technology itself and the relationships and in the representations. You have to see what's going on. And those things are handled fairly straightforwardly. But you do it in an incoherent, incomplete way as an architecture. And so what happens in the cases that actually threaten outage or produce outages of vital services, like the recent AWS outage, we find that on approaching saturation, right, different subsystems and functions behave in ways that dump more load, more overload in other places, and saturation spreads. And your ability to understand it and respond, you get these effects at a distance. I see symptoms over here, but the driver is over here. The trigger, what's really interesting as you grow and processes of complexification in providing critical and valued services, is that often it isn't a fault that starts this. Right? That's why you say, I didn't know the system worked this way. It functioned as it was designed to function. You just didn't know. And that's an old
based
line
on
about
flawed assumptions.
That's right. So we started with systems and thinking. So here's an old line about systems. A system does what it was designed to do. It's just not what anybody intended. So that's a definition of systems for you.
There you go.
You wanted one. I delivered.
Stephen Townsend, who has a great podcast called Slight Reliability, a little play on words for us there. He asked me, because I was a guest on his podcast talking about burnout, and he asked me, he said, I've heard that systems thinkers, so he kind of ascribes this systems thinking to a set of people. He said, I've heard people say that systems thinkers tend to be more likely to burn out. And I thought that was really interesting. My reflection to him was, look, if you feel like if you're somebody who sees things and how bad things can get, or if you're somebody who kind of looks 5 steps ahead and like sees outcomes that maybe not everybody is always able to lock into, right? Then it could be easier to get exhausted if you feel like nobody's listening to you or nobody's helping you.
I think the Greeks had something to say about this. Wasn't that the story of
the term
Cassandra?
Yeah, that's the term that I used.
Looking ahead, seeing ahead is important. Seeing ahead is not making a prediction. Seeing ahead is seeing about how possibilities are unfolding given the constraints. In our real world, you can't just jump from A over to W, right? You have to go through intermediate states. We exist in various kinds of spaces, and there's continuity over states in those spaces. So looking ahead is absolutely critical. It's the first thing we see when we looked at what goes on in responding to anomalies, whether we're looking at it in energy systems, in your world, when we started looking there, or when I started working with Richard and looking at it with anesthesiologists in the operating room. What did we find in 1990? Right? That, expertise in anesthesia is about anticipating so that you can be poised to adapt should something happen. Because if you have to generate the responsiveness to address failing physiology in the middle of the failing physiology, you are going to be too slow. And we are getting very close to what I want to premiere on your show. We've mentioned a couple different attributes of it.
All right.
Right? Because what happens, right, if you're late at dealing with a physiology that's starting to collapse, right? Well, a bunch of things are going on simultaneously that you have to deal with. You might be doing the right things, but can you do them all in the time available? Congestion. So one of the ways that we can connect the science fundamentals, right? This is the way this world works. We may not like it. We may wish it was some other way. We may want to pretend for a while that we live in a different kind of world. But in fact, it works certain ways. And it's just the way this is. If you can find a way to a different universe, good luck. But if you want to survive in this one, this is what you need to take into account. And so a heuristic course leaves things out, but a heuristic to sort of bridge between the new fundamentals that shock people about how this world works and the need to be pragmatic and do something different that will work to handle the forms of complexity as our systems grow and have the potential to provide more value, but also exhibit new forms of vulnerabilities. Okay, what goes on? And it's the messy nine. So we're going to explain the messy nine.
The messy nine.
The messy
Love
nine.
it.
It's like the Chicago 7, which I thought might be appropriate. So, at a formal, sort of explaining it, the simplest is to say the messiness of the real world is conserved over attempts to improve systems. So take any system you want to look at any scale. And you go, I want to make it work better in various ways. This is the process of searching for better fitness in a landscape. And so given what's going on, other parties playing in that landscape, the changing the dimensions of that landscape, how do I get more fit on certain dimensions? And the idea is that the oversimplification or myth is that we can come closer and closer to perfecting our fitness to the world. You referred to an example a moment ago in the business world. And of course, the real finding, the real theorems, the real theory about how this world works says, no, that's not the way it works. So it's very simple. You can say messiness of the world is conserved over attempts to improve it. And this is shown in various theorems like no free lunch and robust yet fragile, and the other theorems, for example, in the theory of graceful extensibility. Now, what does that mean and what can you do with it? Well, a very simple way to think about it then is the messy nine. And I introduced the messy nine by saying, hey, if you, a story of technology change or a story of system improvement should capture or envision, back to that anticipation, the new forms of congestion, cascade, conflict, and there's 6 more, that arise when apparent benefits get hijacked. Now that line has a bunch of meanings in it, right? So there's the forms of messiness, and those forms of messiness will arise after you build out what you intend to be an improvement, right? Which may or may not have benefits that you think it's going to have for other parties. But those other parties might find, if you have real capabilities you're delivering, success, that gives them advantage, that they, things they can take advantage of in new and different ways. In other words, they'll use your new capability opportunistically. And in the end, that ends up generating more messiness. So messiness reappears, is conserved over periods of change. It doesn't get smaller. The dragons of surprise don't get weaker and more infrequent. These are not about tales of the distribution, 500-year events, right? This is
we become victims of our own success.
This is Lauren's law. Yeah.
Right. This is so instead of, if you want to frame it in big things, there's complex adaptive systems, which is very noun oriented, right? Typical classic management speak. Let's squeeze dynamic processes into a noun. What's complexity and who's adapting and what parts of this are complex? Is it, complex adaptive system?
Artificial intelligencing doesn't really roll off the tongue.
That's right. What system is this?
It's
all in that box on the diagram. It doesn't look complex to me.
Sprinkle the AI on. Sprinkle the AI on where sprinkle is the operative verb.
Yeah. And so instead we have, if we want to play a 3-word trio, it would be growth, complexification, and adaptation, right? Which of course is adaptation, which can then lead to growth, but growth, messiness reappears. And that's the form of complexification, and that's the history of your world. It is playing out. The future is already here, right? We can see it. I don't have to anticipate it. I don't have to envision it. I can see it play out in your world. And when I see it, I see these regularities, these principles, these laws, like the law of stretch systems that I illustrated a moment ago. We see these things, and they are general. And we can see the fundamentals about this universe that allow us to derive why we observe those laws and why we see them in the operation of different worlds, natural laboratories, where this stuff plays out. So with that setup, what are the messy 9? Simple heuristic, 3, 3, 3. Right? Congestion, cascade, and conflict. Saturation. What? Those? Well,
all C's.
Yeah, that's lucky.
I know. I started out trying to be alliterative. It didn't work.
Oh,
it didn't hold up.
We fall off that train pretty quickly then, huh?
All right. But it's modern poetry.
Congestion, cascade, and conflict.
Saturation, lag, and friction.
Saturation, lag, and friction.
Tempo, surprise, and tangles. Got 2 T's in there anyway.
Surprise, and tangles.
So let's take the AI gold rush. What has happened with the? Well, we could pick another example, right?
No.
Well,
we have to. We actually do have to. It's happening whether we want it to.
We keep making a hand raise to the elephant in the room. Is AI the AI Gold Rush 2, number 2, second one I've lived through. I've lived through several tech gold rushes, and been part of and had interesting places to sit to see local out views, but also regional views of what really goes on. And these are in papers. Some are 25 years old. Um, and so think about what's happening, that the gold rush is a story of mass, not intelligence, right? Mass data, mass computation, mass energy, and masses of money. And what's going on as this gold rush dynamic process developing because of excitement about a new capability and what it could bring and mean. And they are all saturating, right? I've run out of data. I've scraped all the data. I have cascading effects, and we'll come back to that one. We have various forms of conflict between different stakeholders, such as, hey, since I scraped your data, it's of value to me because of the services I can supply, but I don't pay you for it. Right? 2 weeks ago, Sam Altman talked about the crisis in computation. I don't have enough compute cycles, right? I might have to give up on being able to cure cancer via LLMs and Gen AI in the future. And of course, people immediately responded, you don't have the data. The data doesn't exist already. We have to generate, we have to do studies, we have to do analyses, we have to do new syntheses in order for you to have data for these algorithms to play with.
Don't say that out loud.
What we see in all of these things is forms of saturation. They are approaching saturation, and what we're seeing is mostly the kinds of local adaptations. Oh, I need more computation. Oh, wait a minute, I'm energy limited. Oh, let's invest in more energy systems. And what do we end up with? Tangles.
Tiny nuclear power plants.
I was going to say a conflict with local people who don't want AI data centers. Like there's a whole bunch of these. Yeah, these are hitting.
But look at the tangles in your world as AI is going to code for you. The software engineers operating, right, layers of critical digital infrastructure. And look at it on energy. The energy people, this Friday, said to me, right, the only way we can scale energy production in a cost-effective way is to reduce personnel and use AI. Now, wait a minute. Did you notice a circular dependency here?
Yeah, when do your tokens run out for that energy generation? Because I know people who have like 2 hours using Claude Code before their tokens run out, and then they're like, well, I guess I can't work for the rest of the day if I have to use Claude Code for everything.
Nice example of saturation.
We're optimizing the energy, but why did you stop? Because the AI that we're using to operate the energy ran out of energy.
Right? I mean, so it's very vivid. What is going on in your world, which is, right, the circular dependency is we need to have critical infrastructure in order to support, right, AI-based LLM computations, Gen AI computations. That's what you operate, right? Their stuff puts new stresses on those layers of infrastructure, right? So we have growth, complexity penalties, complexification plays out. Oh, we can solve that by increasing your productivity or reducing the number and expense of the people and experience of the people who do this. And because we can have artificial coding. Oh, wait a minute. The artificial coding is there in order to support the computations that provide the LLM capability to various kinds of users. So we see a classic of growth and complexification where we increase the tangles and we start to produce circular dependencies and strange loops. Where did I first see strange loops? I saw it first in nuclear power plants, right? When we were dealing with it and redesigning it, we saw this kind of thing where a function depended on a version, an instance of itself. The key high-level function depended on an instantiation of that function down in it. And this particularly comes to the fore in accidents, we could talk about. What happened when I started working with Richard and studying anesthesiologists? We saw strange loops because the cardiovascular system is a strange loop, right? It provides oxygen to vital organs, except the heart is one of the vital organs, so it provides oxygen to itself, which leads to the paradox of a sick heart where the surgical team and anesthesia team want to simultaneously keep heart rate high and low, right? It's a sick heart, so keep it low. It's a sick heart, so keep it high, so it will get more oxygenation. Wait a minute. And how is that solved? These cases are solved not generically, not in principle. They are solved on the fly, in the real world, in a balancing act that goes on.
By people.
That falls outside the nouns.
By experts. Yeah.
So
I think about in our world like metastatic failures where we know they can happen. And so you have experts will recognize that they're starting to happen before they go into that cascade. And you'll see them pull them back with little actions, right? And I look at what AI's operations are trying to do, and I'm like, how are they going to know that those variables are changing under their feet all the time, right? That's the thing that like the experts tend to do. So I see that tangle and that strange loop play out in our world, just like those.
So we're seeing the story of the gold rush at a societal scale run into saturation. Also notice the lag. Everyone has aspirations, envisioning what benefits may flow. And what do? You see stakeholders go, oh, I can take advantage of that. So what do? I anticipate productivity gains, and those can generate economic resources to extract. And so what do? I start cutting experience, expertise, and people before I have integrated in the ostensible new capabilities, not recognizing the difficulties, other forms of workload, congestion, cascading across lines of interdependency and conflicts that arise, and trying to bring this capability into complex worlds of practice. Because I underestimate the offsetting costs and bringing this capability in, I end up with this lag problem where I cut the resources I need to integrate in the new capability to discover what actually would be valuable and how to have that work as a full integrated system embedded in a changing, highly interdependent world, where if I'm doing it well with good capabilities will stimulate more change, more adaptations, more development, and the cycle continues. Again, growth, complexification, and adaptation, these cycles are intermixed. And I think that's a better way to think about what was called complex adaptive systems. And the simple heuristic, again, congestion, cascade, conflict. Where do the conflicts arise, right? Who loses in that? Right? Who sacrifices? What gets prioritized? When there's shortfalls, when there's overload, right? What gets sacrificed first? What gets sacrificed later? These dynamics play out. Saturation, lag, friction. Notice there's a lot, as people try to bring AI capabilities forward, what do we keep seeing? All right, lots of commentary, which can be summarized as there's a lot of friction about putting these things into practice. It's not easy. The real world has this. It is a necessary feature, and if you underplay it, the things you try to deploy turn out not to work out as well as you would like. So tempo, surprises, and
pretty
tangles.
Hard for me, Dave. I didn't mean to interrupt you, but it's just I got to stop for a second because I have literally been told this recently. We have to increase our productivity using AI, otherwise we're going to have to cut some people. Yeah. Because like we just it's you have to be more productive, right? And the only way we see that happening is with AI, and it's sort of like, wait, but don't you want more done? like
if you can either have more,
you can have the things getting done, or you can have the things not getting done.
You can use AI.
But there's this false belief that no, I'm going to put pressure on you to get good with AI, to sprinkle the AI on now, right?
Yeah.
And they're that the misunderstanding of that lag is massive. It's growing day by day, and it's
Lag,
kind of
friction.
understandable that leaders, because they're being told, they're being sold a thing, right? But it's landing down here at the layers of adaptability, where we know we could probably get something out of it, but we need time to build that expertise, just like every other automation system. And right now we're in that lag, so that's just that one's hitting pretty hard for me.
Tempos.
I wish you were in the previous webinar, Clint, saying that exact same thing.
Yeah,
I'm so glad I'm not employed right now. I'm just gonna put that out there.
The tempos are classic. ULIV and DevOps developed by linking development to operations, so that a tempo of operations now influences development. Development becomes part of operations. Operations becomes a constraint on development, right? And incident response, we have the tempos vary. And right now we're talking about different tempos of absorption, tempos of development, right? Oh, I can rush the deployment out. And so we see collisions across and congestion across those tempos that are in play. And so we end up with the Messy 9 as a kind of translation heuristic from, the fundamentals, which we can express in different ways and try to explain and illustrate. But I want to say these are actionable, because each of those words and their interactions and interdependency point to processes that play out over time. They point to verbs. They point to gerunds. They point to adverbs. How does this go? In the process of moving forward, you will encounter friction, and so it will take longer than you think, right? And there will be friction also means there will be offsetting costs and workload that you have to deal with. If there's offsetting workload, that's going to create more congestion, because you only plan for this kind of load and this, right? And the more workload, right, and congestion that creates, the more saturation arises. So how do you adapt as you approach saturation? So you can see in these words the ability to look ahead, that the most important thing is to look ahead. Yes. And so no, I would come back and say, no, it's not Cassandra. But when you look ahead, there are days or evenings when all you can do is walk outside and scream into the void. Because you can see ahead, right, what others are racing towards. And right now, from a safety perspective, if we put this in high-risk worlds, right, our line is we are racing towards systems and safety engineering malpractice, back to that systems world and systems thinking, right? That systems thinking in the textbooks, the handbook of systems engineering, is about linear combinations. How do you put these pieces together to make the big whole? What they don't do is talk about the time effects and how this stuff plays out. And right now, the narrowing pressures, the speed pressures, the extraction of profit pressures, the workload pressures, all of these things mean we are racing towards systems and safety engineering malpractice, a collapse, a brittle collapse, we are in a viability crushing race right now. And what does that do? It puts more and more pressure on the human roles that are willing to step up and try to insert the extra extensibility, the graceful extensibility, the resilient performance to keep these things working under more and more difficult conditions, right? And it means that more and more points of brittle collapse will occur. Now, the brittle collapse will have the qualities of the AWS outage. And that's something that worlds like aviation and air traffic control and healthcare really aren't, it's not on their horizon to understand that using up the apex of pushing certain AI capabilities forward brings with it this whole tangle of interdependencies across layers of infrastructure, that where things can break down in ways that will take out in one incident wide swaths of functionality that underpin critical services. And this is a pattern that plays out. When you look at these things, you can see other kinds of patterns over time, like the slide to criticality, right? What starts out as nice to have, right? And then eventually people find how and where that fits into frontline activity, the frontline way to do your business, right? Well, once it becomes frontline, it's only a moment's glance before it becomes activity essential, activity critical, business critical. We can't really function, or we can't have the same levels of throughput, the same levels of efficiency and profitability without that capability. Eventually, the system runs out of its ability to work in the old way. So for a while, you're in an intermediate state where it hasn't been a ratchet yet, and you can slide back. And you can pull out the old ways. People have the experience and the memory, and some of the tools hang around. Richard had an example that fax machines hadn't disappeared from the digital hospital yet. So when the whole computer system for the whole hospital went down, you could still ad-lib the old ways of doing it by faxing orders to another part of the hospital, faxing requests for medications from pharmacy. You could still do the communications in other ways.
That's why I'm always keeping a landline phone, by the way.
Go ahead.
Yeah.
What's that?
Yeah.
That's why I'm always keeping a landline phone, by the way. Our new house.
Yeah.
I told my husband we're going to have a landline there, and he was like, what? And I was like, no, we've got to have one.
Well, there's different.
Yeah, it's like you read articles about hospitals bringing the fax machines back after like getting owned, like all their systems get locked up by hackers, right? They
hackers.
Can't do, and immediately the people adapt, right? They're like, well, we'll write things on paper, and then they think, well, I think there's maybe a fax machine over there, right?
Somewhere.
Like those, you're right, that we're still in those
closet.
transition phases, even in that world. And we'll be in that one with AI for a while. And it does make me feel good about job security until I'm ready to retire. But like that transition time becomes very expensive, right? Like
the messy 9 says the issue is whether your specific job, right? Right. But the jobs like you do today will still arise and be critical, because the messy 9 will be there no matter what. The messy 9 will be there, and the interactions. Messiness is conserved over cycles of change. It takes new forms, and it operates at new scales. And that puts a higher premium on the experience, skill, and expertise to figure out, how is it working when it's not working the way I thought it did? That's a very special kind of expertise, right? That's not what's normally talked about in discussions of expertise, as happened an hour ago, right? That is about uncertainty and ambiguity and novelty, and right. And the system is misbehaving, right, in ways that indicate I don't understand how it's working. It's malfunctioning, and the failures that may have triggered it are failures that normally don't matter. The system is robust. The system adapts around those. Yes, there's some degradation here or there. You understand that, but you have time. You have opportunity. No one sees the threat of an outage or an actual outage of valued services. But when the systems become complicated enough that you can have malfunctions and misbehavior that lead to loss of valued services without any, quote, fault or root cause. The root cause is, right. The system works as it was designed. It's just not the way anybody intended.
The root cause is always capitalism, Dave. That was my line I learned to all my classmates. I'm gonna wrap us up, because this has been a really cool, really sweet conversation. And I'm sure whoever listens to us and wrote in what is systems thinking didn't expect us to necessarily produce this as an answer, but I'm so delighted that we did. I want to say a big thank you to you, Dave, for joining us. It's a real honor. We'll have to have you come back again soon. John, we're going to make you come talk to us again soon as well. As per usual, you're just Kramer coming in the door.
John had a line. John had a little line we were going to play for you.
Oh,
John,
I don't know. Wait, Dave, you can't prompt me after. You can't prompt me at the end of the episode.
Well, we have a line that we have to do, which is this is finepod.com. Please come ask us more questions. If you want Dave Woods to answer a question, now that you've heard this wonderful answer to what a system's thinking, please.
Yeah, we take guest requests.
We'll take your guest request. And we need more questions because otherwise we don't have a show to do for you. And please like and subscribe us on our whatever platform you choose to listen to us on because it's helpful. Okay, that's my plug. John, did you remember what you were going to say?
I didn't, but I do have something. I do have something to reflect to the question asker, to the extent that it helps. David and Clint and Colette demonstrated what systems thinking looks like today. That is what systems thinking looks like. I will say, and just as I want you to know that I did make an attempt to make a mnemonic for the Messy Nine.
The Messy Nine.
The best I could come up with is colleagues catapulted croissants like sparkly floss and tricked samurai theatrically. That's as best I can come up with.
All right.
So,
it's incredible.
I think it's just
maybe our listeners can contribute some.
I think it's just as easy to remember congestion, cascades, and conflict, saturation, lag, friction, tempo, surprises, and tangles.
We did just get a store for the Resilience and Software Foundation.
merch.
So maybe, maybe we'll have to make it into merch. Stay tuned for
a Messy
that.
Nine shirt.
John, you were speaking of merch, you were supposed to say, right? So, you were looking for an opportunity as we talked to say that I am the breaker of plans.
He is the breaker of plans.
Yes.
And then I was supposed to respond, and now I forgot what I was supposed to respond with.
No, you respond. I mean,
the best
thing
laid
plans.
Is
that what's irony is that I was late on getting to the call because the world broke plans.
Didn't want you to have a parking spot. Yeah,
just surprise.
Disruption. Yes, yes. You see now why I take a lot of drugs.
Well, but no, I do remember my comment was because I don't break the plans. The world will break your and my and everyone's plans. It's not me who breaks them. The world will. And especially when you do good things, that just fires up the world to break the plans that you so carefully laid. So that was supposed to be the ending.
All right. Well, dear listeners, I hope we didn't break your plans. We'll see you later. Thanks guys.
Thanks so much, Dave. Thanks, John.
Thank you.